Now, before we get into, more complicated versions of the PXY diagram, I think it's important to just go over how exactly we should interpret what these diagrams are telling us. And so in order to guide you through how to interpret this diagram, we're going to consider a process in which our binary mixture undergoes isothermal compression. And I'll guide you through each of the steps of this process. Okay? All right, and so if we take a look in the diagram on the right-hand side, that we sketched up before, essentially what we're going to do is we're going to start in the part of the diagram that's marked out by the letter A here, right? And so that'll correspond to, a mole fraction x1 is equal to 0.5. So we're equal molar in our mixture, okay? And so in this part of the phase diagram, we're in the region where we have entirely vapor. And so at point A, what we're going to, if we were to sketch out what this process looked like, or what the system would look like, imagine we have a piston cylinder where the pressure is really low. Okay? And so because the pressure is very low, the mixture inside this piston cylinder system is going to be 100% vapor, right? The molecules have a lot of room to be spread apart, and so because they're very spread apart, they form a vapor. So here, y1 is equal to y2 equal to 0.5, right? And we're 100% vapor, so that means that our liquid mole fractions are equal to 0. Okay? All right, and so, that's where we are in point A. But then let's say what we do is, since we're looking at a piston cylinder system, let's say we apply some force onto the piston so that way we increase the pressure on the system. Okay. And so what we're doing in the phase diagram is we're just going to go straight up, and we're going to go to point B. And so in point B, the system looks like this. So we have some sort of force on the system that's larger than the force that was on the system in point A. Okay? And so we've now increased the pressure of the system. And so while most of the system, is a vapor, we hit the line in which the vapor starts to coexist with the liquid, right? And so essentially we hit a critical pressure such that we reach the point where the first droplets in our mixture begin to form. So we start to form this liquid phase. All right, and so the pressure at which this happens, in which the first droplets in our mixture begin to form, this is known as the dew point. Okay, so the dew point would be the dot B in this diagram. Okay, so the dew point is when your first liquid droplets form. Right? And we're forming droplets, and originally when we started this system, we were at a vapor mole fraction of 0.5. Okay? But let's say that we were considering a system in which, as you could see here, the vapor pressure of species 1 is less than the vapor pressure of species 2. Okay? And so what that means is that species 1 is less likely to be in the vapor phase than species 2. And so we would say that species 1 is less volatile. Okay? Alright, and because it's less volatile, that means that species 1, it doesn't take that much pressure in order to get species 1 to turn into a liquid. Okay? And so at this dew point, what we see is that the first liquid droplets that form, those liquid droplets are going to be concentrated in species 1. Okay? And so species 1 is less volatile. So it more readily condenses into liquid. And so as a result, the liquid droplets are enriched in species 1. Okay? So that happens at the dew point. Alright, and so as we increase the pressure, more liquid is going to form, but that liquid is going to be more concentrated in species 1 than it is species 2. Okay? And so if we try to increase or we apply a stronger force onto the system, rather than just directly increasing the pressure straight up, what we would see would happen is we actually, as soon as we hit the vapor line first, as we increase the force, we actually go sideways, okay, until we hit the other line. And so if I mark out region C and region D here, we could draw what they look like. And so in region C, we're halfway between the vapor and the liquid lines. And so our mixture in the system ends up having large amounts of both the vapor and the liquid. Okay. And then, if we keep increasing the force on the system and we go sideways, we eventually reach the part of the phase diagram when we're on the liquid line. And so here, what it would look like is then most of our mixture would be mostly liquid, and we would have only a few bubbles of the vapor. Okay? And so in region D, this is known as the boiling point. So the boiling point is when the first vapor bubbles form in the mixture. Okay? And then, if we keep increasing the force on the system, and we go up, we see that the entire system turns to a liquid. Okay? Alright, and so, as we go to those different points on the PXY phase diagram, this is what is happening physically inside the mixture system.